All right, the last lesson of the year. Normal distribution we need to discuss, and there's a very little bit that you need to add to your knowledge for your final exam. We talked a little bit before about this one day when I was asked a question about, well, how could isn't everything based around the mean? Well, it is all based around the mean, but if you notice, if you're connected to these little boxes, the shape would start to kind of look like the one at the end. See what I'm doing there? That was last hour. Yes, she's in my 6th period. Yes. Okay, the normal distribution, excuse the interruption there, where distributions of mileages of different sample sizes of cars are shown below. As the sample size increases, the distributions become more and more symmetrical and resemble the curve at the right. And that's due to the law of large numbers. So you see how this one, if you connected all those, it's getting closer and closer to that shape. You don't have to draw this, guys. I'm just showing you. This is the bell curve. Now, on this curve, this would be the mean. Also, the median. And the mode. They all converge into one. They're all one thing. Mean, median, mode are always right smack in the middle of the normal curve. Now, everybody isn't the mean. The mean is the average, all right? It's the most mid term of the data, middle term. And so all of the other data is based around it. Okay, so everything to the right of the mean is on the right side, and that would be half the data, and half the data is to the left of the mean. Okay, so there's always data that's not smack on the mean. That's the curve at the right is the normal distribution. It's a continuous, symmetrical, bell-shaped distribution of a random variable. It's the most common continuous probability distribution. The characteristics of the normal curve are as follows. The graph is continuous, bell-shaped, and symmetrical with respect to the mean. The mean, median, and mode are equal, and it located at the center. The curve approaches but never touches the x-axis, and the total area in the curve is 100% of the data, or 1. The area under the normal curve represents the amount of data within a certain interval, or the probability that a random value falls within that interval. The empirical rule is this. It is in a normal distribution with mean of mu. Now, they're calling this mu, that's a Greek letter. That's your mean, which in your calculator was x with a bar, okay? That's your mean. Okay, and it would be located at the dead center of the normal curve. Remember this little symbol? A lowercase sigma? That was your standard deviation. Okay, it is a value that you use to go plus or minus from the mean. So to get what these are, notice down here, the mean is in the middle. One standard deviation above the mean, it would be mean plus a standard deviation. That's what that stands for. Okay, this would be x bar again, or the mode, mean, median, and mode. Okay, I don't know what that was. All right, mode. They are all at the same value. Approximately 68% of the data, I'll show you what these things mean. This is what you're going to need to be able to understand on your sheet for finals. One standard deviation to the left and right of the mean comprises 68% of the data. When you go 2 standard deviations from the mean, you have now encompassed 95% of the data. So that means that 13.5% in addition on the right and 13.5% in addition on the left. You know where that number just came from? 95 minus 68 is 27. Okay. 27 divided by 2 is the 13.5. You're going to have to just be able to figure out, using this, how much of the data lies within a certain range. Okay. 3 standard deviations from the mean is really far out. Remember those things we called outliers? They're the weirdos. They're outside the normal stuff. Get it? Outliers anywhere. They're odd. They're way out on the side. So if you're past 3 standard deviations of the mean, you are skewing the data. You're messing with the data. So you're really outside of the norm. And I don't mean you personally. This is where 99.7% of the data lies. So how much is not included within 3 standard deviations? Only 0.3%. Okay, so only 0.3% or 0.15% on either side should be outside of 3 standard deviations. Is outside plus or minus 3 standard deviations. All right, so noting those percentages and being able to mess around with them, that's what you're going to need to be able to do. And it's really just one question on the final that'll have you looking at this chart. This is on the final, your formula sheet, right? Okay, know where it is. So it says the normal distribution has a mean of 21 and a standard deviation of 4. That would mean that this is your 21. Where'd the 17 and 25 come from? Well, it came from taking 21 plus or minus 4. So if you were to find, this is an example, find the range of values that represent the middle 68% of the distribution. So the values of x would be between 17 and 25% when they're within 1 standard deviation. What percent of the data would be greater than 29? Well, if I extended this diagram here and kept going 4 more, if I went 4 more to the right, at 2 standard deviations, we'd be at 29. If we went left, that'd be 13. And this would represent, if you went to 29, you're already at 2 standard deviations from the mean. 50% would have been on the left side. Remember, half the data is on the left of the mean. So they have 50% of the data. Plus, then what's between here? Well, if 68% is between 1 standard deviation, this would be 34%. Agreed? And then we knew that between 2 standard deviations was another 13.5. That's be 13.5%. You're looking at your chart, right? That's how you use it. All right, so what it would be beyond here? 50% plus, let's see, 47.5. Okay, that's 97.5% used up. So they went 100. You could have done it like this, 100 minus 97.5%, and that's where they get the 2.5%. Okay, or there's another way to think it. At 2.5%, since you know that 95% of the data is within 2 standard deviations, I'll show you another way to think it out. Okay, from here to here, that's 2 standard deviations plus or minus. That would be 95% of the data according to your empirical rule chart. Then you would only have 5% left at each, and so you'd have to divide that by 2 to get 2.5. For whatever way you see it. You see, maybe you like that better? Okay, so if you know 95 is within 2 standard deviations, you have 5% left for the tails, which you have to share 2.5% on either side. Okay? A normal distribution has a mean of 8.2 and a standard deviation of 1.3. We're going to do our own. All right, so let's draw one together. I'll make a little bell curve. Doesn't have to be beautiful. Okay. I'm going to label the mean. It says normal distribution with a mean of 8.2. It has a standard deviation of 1.3. So we'll take the 8.2, add 1.3 to get 1 standard deviation away. And that's 9.5. Now let's go to the left also. 8.2 minus 1.3 would be 6.9. And then let's go out again. 2 standard deviations away to the right, we'd add another 1.3. So I did 8.3 minus 1.3. Now I'm going to do another addition. It's at 10.8. And then where would 3 standard deviations be? 12.1. Okay, going in the other direction, 2 standard deviations to the left would have been 5.6. And then one more would be 4.3. Okay, so this is 3 standard deviations. This is my 2 standard deviations. This is 1. And these are the negative side. This is plus 1 standard deviation, 2 standard deviations, 3 standard deviations. Okay, any problem with how I got that stuff? All right, now it says find the range of values that represent the middle 95%. So you look at your empirical rule. How many standard deviations away is 95% on both sides? 95% is 2. So you would go to 2 standard deviations, left and right, and that would be the answer for A, would be between 5.6. So X is between 5.6 and 10.8. Those would be the values. Part B says what percent of the data would be less than 4.3? Okay, so that's behind the standard deviation of 3 to the left. They're asking for this section right here for Part B. Well, that's 3 standard deviations, but from here to here is 97. What was it? 99.7% of the data. So if we did 100% minus 99.7%, only gives us 0.3%, and that has to be shared amongst both ends that are beyond 3 standard deviations. So what do we have to do to this to get just the left side? Yeah, we have to cut that in half. Oh, sorry, that's 0.3%. So that would be 0.15%. Significantly smaller than 1% of the data lies outside on that side. When we get where I know where, anybody have a question about how I got to 0.15? It is not convert, you do not convert that to 1.5. It is already in a percentage. Okay? Don't move the decimal. As a decimal, it'd be 0.0015. All right, let's look at a couple more. These are really done for us. So want to just do another example together? You could actually read these if you felt like it. And then I can start showing you your quizzes and stuff like that. All right. These have the answers on them. Oh, wait, never mind. I'll go over it because we have one at the bottom. All right, let's do that one. The number of friends per member in a sample of 820 members is normally distributed with a mean of 38 and a standard deviation of 12. All right, let's get our picture drawn. Okay, so I'll put in mean of 38. Standard deviation of 12, so 1 standard deviation to the right would be at 50. 2 to the right would be at 62. And 3 to the right would be at 74. Now I'll go left. Subtract 12 from 38 and we get 26. Subtract 12 from 26, we get 14. And then 3 standard deviations away would be 2. Now I know my picture's not perfect. I heard some very high-pitched voices there. About how many members have between 26 and 50 friends? Okay, now 26 and 50 is 1 standard deviation, which would be 68%. So if part A, we want to know how many of the people. There are 820 members. we would do 820 times 0.68. Someone do that for me. I've done it before. I could tell you what it should come out to. How many people? How much was it? 500 what? 558 people? Okay, part B. What's the probability that a random member will have more than 14 friends? Okay, more than 14 would be everything to the right of 14. Now, how do we figure that out? Well, you can look at your empirical rule. On this side, that would be 50%, right? I just need to figure out what's in here. So between two standard deviations is 95% of the data. What's half of 95? 47.5. Was it early out then? Bye. Have a nice weekend. See you on finals. 40, that'll be the first day. Oh, we do have our final on Monday. All right, what's the total here? 97.5% have more than 14 friends. All right, the next thing in here is you do not have, and we're not going to calculate z-scores, but just to have a little heads up about the future if you're taking probability and statistics next year, z-scores are simply when you find the value or where the data is in a distribution, how many standard deviations within the data it is. Not everything's going to land right on those perfect intervals that we labeled, right? There's going to be stuff and answers in between there. And so that's what that calculates for you. All right, so this is what you need to know for your final. Now we're going to get our quizzes back. So have a nice evening, and Heimer time is over.